We left off that we've asked the decision maker two questions, one to get his utility for 90,000 and the other one geared towards getting his utility for 50,000, but we never quite answered what is the utility of 50,000. So in order to understand what's going on, we really need to look at the decision tree. And the decision tree is telling us that if he sells, then he is going to win 90,000. But he's already told us that 90,000, he's indifferent between his 90,000 and his 70% chance of winning 200,000. So if that's the case, what we can do is we can replace the 90,000 with that gamble directly. Because it doesn't matter. He's indifferent between 90,000 and the gamble. And the same thing up here. If he wins 50,000, he is indifferent between keeping 50,000 and winning 90,000 with a 0.9 chance. So we can take this 50 out of the equation and just replace it with this gamble here. Now, of course, winning 90,000 is again equivalent to 0.7 of winning 200,000. So again, we can just cross this out as if the tree looks the way it does now. And we see here that the utility of keeping is then the equivalent probability of making 200,000 with the keep option. We're going to go with the keep option. What is the equivalent probability? He's indifferent between keeping and this tree here. And this tree translates into a 28% chance of winning 200,000 and a 0.72 times 0.9 times 0.7% chance adds up to 73%. So he's indifferent between keeping and getting a 73% chance ticket on a $200,000 gamble. If he goes with the bottom choice, selling, then the equivalent probability of making 200,000 is only 0.7. So therefore, clearly he's going to keep. So this is all from these indifferent statements. Now, to get the utility of $50,000 is equivalent to a 90% chance of winning 90. But once you get the 90, you're going to trade that in for a 70% chance of winning 200. So therefore, it's indifferent between keeping 50 and a 63% chance of making $200,000. So that answers our question of utility of 50. Now, normally what is done is, this logic was to explain how it's used. Normally, we would go back to a decision tree like this, and we would say, okay, we now know that the utility of 50,000 is 0.63, and we know that the utility of 200,000 is 1, and we know that the utility of 90,000 is 0.7. So we would just take 0.72 times 0.63 plus 0.28, which is going to give me 0.73. And then we would say then that we would not use the expected value. It would lead to the same conclusion. That it's better to keep than to sell. But at least we now know this calculation has taken into account his attitude to risk. So you've seen both the rationale for using utility functions as probabilities, and you've also seen how we would actually use it directly once you had the utilities.